All right, in section 2.2 in Trig, 2.2 is very similar to 2.1 in that it has to do with trig identities, but 2.2 uses language that says like verify each identity. So what you need to do is you're going to be given an identity. You're going to be given an equation that essentially says, hey, the left equals the right hand side, or maybe they're asking you to demonstrate that the left hand side equals the right hand side. So that's kind of what verify or prove or show that this identity is true by showing that each side equals each other. So very similar to what we did in 2.1. What you need to do is change one side, or sometimes you can change both sides so that you get the same thing. Show that they're equal. So typically what you do in these situations is you pick a side. You usually pick the more complicated side or the larger side, and you try to simplify that expression. So in this identity here, okay, I'm just going to show you two problems that you can just write down as examples. On the left-hand side here, I'm just going to take that expression and just simplify it like I would in 2.1. And I know what I'm trying to get here. I'm trying to make it so that it equals cotangent right there. So it's, in a sense, it's almost easier than 2.1 because you know what you need to simplify it down to show that it works. So if I take the left-hand side and I start using the strategies that we talked about in 2.1, that would be things like Pythagorean identities, doesn't apply here. Factoring, can't do that here. I would probably start changing everything to sine and cosine in this problem. So I would look at secant and I would look at tangent, and I would change those to sines and cosines and see what I can multiply or divide out. So if I do that, I have cosine x now times the secant is the same thing as 1 over cosine. So I change that to 1 over cosine. Then this is all divided by the tangent is the same thing as sine x over cosine x. So when you get a problem like this, you get kind of a big complex fraction, and you just want to be careful as you're going through it. Oops. So all I'm going to do here is I'm really just going to focus on the top. I know that cosine x times 1 over cosine x, well, of course, that's equal to 1, right? So my next step is going to say 1 divided by sine x over cosine x. So I went from here, and my next step was now this. And if I have 1 over sine over cosine x, that would just be the reciprocal. So I could think of that as 1 times cosine over sine. So this would equal cosine x over sine x. And this is really what I'm trying to show, is that the left-hand side does equal cotangent x. So cosine x over sine x, that is the same thing as cotangent. So then this is now equal to cotangent x, and that does, you can see that cotangent x on the left, and I was trying to make cotangent on the right, so those are equal. So I'm done. So again, all you're doing is showing that the left-hand side and the right-hand side are indeed the same, and you pick a side, you break it down to show that it equals the other side. Sometimes you can change both sides. Okay, so there's one example. Let's do one more. Of course, there's kind of a large range of problems here, right? There's tons of different types of problems, so you're going to run into lots of types. So can't go over every single type, but the ideas and the strategies are all the same. So taking a look at this example here. So now I have tangent plus cotangent equals secant cosecant. Okay, so in this case, I'm looking at picking a side, and since this has addition in it, it looks like I could maybe combine those and add those things together. Okay. Also looking at the right-hand side and noticing, well, I could change secant and cosecant as well, right? So I'm going to start just by taking the left-hand side and trying to add those together. Before I add them together, I would need to change it to sine and cosine. So this would be something like sine of theta over cosine theta plus cosine theta over sine theta. So I changed it to sine and cosine, right, which kind of made it more complicated. But at least now I could, like we did before, we could add the fractions together and see where that takes us. So if I want to add these fractions, I would need a common denominator. So on this left-hand side, I would have to multiply by sine theta. And on the right fraction, I would multiply by cosine theta. Right? So now I have a common denominator. I got sine, cosine as my denominator. And my numerator, or my numerators, I can go ahead and add. So that would be sine squared plus cosine squared, all divided by the common denominator of sine theta cosine theta, right? Hopefully sine squared plus cosine squared jumps right out at you because that is equal to 1. So I have 1 over sine cosine. And that's equal to the right-hand side, right? Secant, cosecant. Hopefully you can see how that's really going to get to our answer here, because 1 over sine, this right here, 1 over sine is really equal to cosecant of theta, and 1 over cosine is equal to the secant of theta. So the left-hand side equals cosecant times secant, and that's what we were trying to get. We were trying to get the left equal to the right, which was secant cosecant, and so that is done. Okay, so that's verifying trig identities. What you need to do in this section is that worksheet that I gave you, and it's kind of a circuit worksheet. So if you bring that out, so what you do in this worksheet is you start at question number 1, and you look at the problem and you try to simplify it. And the answers, you can see that there are answers around the worksheet, right, in different places. And you're going to simplify it and try to get it equal to one of the other answers on the worksheet. So you simplify it, you get an answer, and then you kind of search to see if you can find that result on your page. And then that would be your number 2, right? And then you can work on that problem. So it's going to jump around the page, and the answer for each question is somewhere on another problem. So let's do number 1, because number 1 has an identity that I'm not sure that we had talked about yet. So it's kind of an oddball in our case, because we haven't talked about what this is the same thing as. So if you know the identities for this, which I don't think we wrote down yet, but the cotangent of pi over 2 minus theta. So I'm just going to quickly tell you what that one is, because I don't think we wrote that one down. But there are, besides the ones that all the trig identities that we already wrote down, there are even more. There's lots more. So there are identities called cofunction identities, which you can certainly just Google trig identities. You're going to see a lot of cheat sheets with just a lot of trig identities on them. I'm going to bring up these cofunction identities, which are right here. Essentially what cofunction identities are is basically saying that there are graphs or these trig functions that are equivalent if you just shift the graph over a certain amount of the period. So for example, sine and cosine are the same graph, right? If I just take sine and I shift it to the left or to the right a little bit, it's the same thing as cosine, and vice versa. You can kind of think about these cofunction identities as that. So the one that I'm looking at here is right here, basically just looking it up, and I'm telling you that the cotangent of pi over 2 minus theta is equal to tangent. So, long story short, okay, that right here just equals tangent. So if we did this problem, we would go down the route of this is sine theta over this is tangent theta. Okay, and then I would just keep going through my strategies. So I would take tangent and I would switch that to sine and cosine. I would say that this is equal to sine, this is equal to sine theta over, and tangent is sine theta over cosine theta. Okay, here again I'm dividing, I'm going to multiply by the reciprocal here. So I'm going to take that top sine theta, and multiply by the reciprocal of tangent, or in this case sine over cosine. So this becomes cosine theta over sine theta. And when I look at that, this product here, I can cancel off the sine factors. So I'm confident that this expression just equals cosine of theta right here. So again, once I get that answer, I'm going to search around my worksheet and just see if there's an answer that is cosine theta, and that's where I'm going to jump to for my next question. So eventually you'd find it. It's on the back, right? There is a little problem or a box that has cosine theta as a possible answer, and that's what we just simplified it to. So then we're going to start here. So this is going to be our this is going to be our second problem that we're doing, and then we would go on and try to verify this identity with another answer somewhere on our worksheet. So basically, again, we're going to simplify that as much as we can, practicing the stuff that we've talked about in the last couple sections, and then see if we can find that on the sheet and go through those problems.